That would have been a great place, for example, for the first creatures from the sea to get their legs. They could have come into a tidal pool where it's wet half the day and dry half the day, and it would have been a great place to grow your legs and eventually move on to land.
According to astronomer Neil Cummins, we can't underestimate the moon's influence on our development as a species.
Without the moon, I don't think that that process would have occurred nearly as quickly. We have evolved so that our biological clocks are based on around 23, 24-hour time. If the moon had never existed, the day would be 6 hours long. And we, as the creatures we are today, couldn't exist.
As the moon slowed Earth's orbit, it stabilized our rotation and affected our climate and ocean tides. And the moon greatly influenced the development of mammals so dependent on moonlit nights for their survival.
Has the moon had a major impact on our existence? I think absolutely.
Every time the moon is full, the lunar image is exactly the same. There's a puzzling mystery to this. It makes many wonder why we never see another side of the moon.
After 4.5 billion years of evolving, the Earth-Moon system has arrived at a point where the moon shows us the same face all the time.
Billions of years ago, the friction created by volcanic tides caused the moon to slow its rotation and become tidally locked to Earth. This doesn't mean our moon isn't spinning, but it has slowed down considerably over billions of years. And the secret of the moon's hidden far side has to do with synchronicity.
If this is the Earth, and if this is the side of the moon that we see, if the moon were not rotating, then eventually we would see the other side of the moon. Because the moon is rotating at the same rate that it orbits the Earth, synchronous rotation, we always see the same side.
The far side of the moon is not always dark. If you were out in space, you would be able to see that the sun hits all sides of the moon as the moon makes its month-long orbit around the Earth. But from where we sit, we can only see one side.
Gravity is in firm control of the Earth-Moon relationship. Or is it? The gravity that has held the moon in our orbit is slowly losing its grip. And the consequences of that are enough to make one look at the moon in a whole new light.
Gravity is a force that holds the moon to the Earth. Just as this athlete is bound to the hammer that is orbiting about his body, so gravity binds the moon and the Earth. If gravity all of a sudden went away, the moon would fly off into space, just as this hammer flies off over the field.
Of course, gravity never stops working, but could the moon somehow slip loose of its grip? The truth is, the moon has always been slowly slipping away from us.
The moon has been moving away, and it's still moving away. In fact, the moon moves away from us a couple of inches every year, and eventually the moon's going to be so far away that it won't even seem like our moon anymore.
Ever since the moon and Earth became intertwined, the energy from the Earth's gravitational tug has been causing the moon to spiral away from our planet. It's currently moving away from us at a rate of 1 to 2 inches each year. The key to this unexpected effect are the tidal bulges created on the Earth by the moon.
The tides on Earth actually act to propel the moon outward, spiraling out further from the Earth every orbit. The reason is because the Earth spins faster than the moon orbits us. So after the moon has pulled up a tidal bulge, raised the high tide, the Earth turns and pulls slightly ahead of it. So there's just a little bit of a forward force, or we call it a torque, a little bit of an extra kick that speeds it up ever so slightly. But over time, that speeding up makes it go faster and faster, which in orbit means it's spiraling further and further away.
Over time, the moon will expand its orbit until someday it will finally be beyond our Earth's gravity. But scientists say there's no cause for panic. Quite a bit of time will pass before the moon is out of sight and out of orbit. Estimated time of total departure, about 50 billion years. And our sun will flame out in less than 10 billion years. Throughout history, the moon has delighted, surprised, and sometimes terrified us. And the movement of our Earth may be the cause of this mystery. Another secret of the moon has been documented in ancient texts and continues to amaze. It usually appears every few years. During a total lunar eclipse, the full moon dramatically changes colors. What causes this?
A lunar eclipse is very simple. It just occurs when the Earth gets between the sun and the moon. So when Earth gets in the way, Earth casts a giant shadow that blocks the sunlight from reaching the moon.
At the peak of this eclipse, the moon passes completely into Earth's shadow, or umbra, and transforms not to black, as one might expect, but to a blood red.
What happens is, some of the sunlight that's being blocked by the Earth actually slips through the atmosphere, and the red light gets through the best.
As the sun's rays pass through the Earth's atmosphere, they're bent a little bit, and the red rays are bent in such a way that they make it over the surface of the Earth and illuminate the moon.
And when only red or orange light reaches the lunar surface, the moon appears red, another optical phenomenon that adds to the moon's mystique. And part of that mystique can be attributed to the dramatic presence of the moon above us. It outshines every other celestial body in the night sky.
There's a special magic to the moon. Its changing phases, its brightness in an otherwise dark sky.
But we also see the moon during the daytime. Why is this?
It's actually very easy to understand why we can see the moon during the daylight. You can do this demonstration at home. All you need is a bright light to act as the sun and a piece of fruit to act as the moon. My face is acting as the Earth. The lit up side is the daylight side and the hardened shadow is the nighttime side. Now the moon, of course, orbits the Earth, and at some of the times during the month in its orbit, it's on the daylight side of the moon. So I'm able to see it in full daylight.
Actually, many planets and stars are just above us during the daytime, but the light from the sun is just so bright that it obscures nearly all of them. Only the moon, which is 100,000 times brighter than the nearest star, shines through. We don't always see the moon during the day because it's constantly moving around our Earth, and it's not in the same position at the same time every day. But somewhere on the planet, it's always visible. But as we've learned, not everything about the moon is easy to explain or understand. There are still plenty of questions left unanswered. It's been part of the moon's mystique since history was first recorded. We are forever tied to our neighbor, but we know so little about that dependence.
There could be other things that are happening that we just don't know about yet.
Over the next century or so, I think that science is going to take us further into understanding its mysteries. Whether we will fully understand it, I doubt it.
I certainly don't think we know everything there is to know about the moon. There's a tremendous amount to learn. But fortunately, it's within reach, and we will go exploring it further and learn a lot more about it.
Until we rekindle our efforts to explore the lunar world more thoroughly. We may never know all the secrets or hope to solve the hidden mysteries of the moon.
ללבוש.
That is really, really loud.
מסכת ברזל.
You need to get out of that?
לנשום.
I think I closed my eyes.
מתחת לגיליוטינה.
Like my life flashed before my eyes.
יש אנשים שזאת העבודה שלהם.
I've had enough. Get me out of this thing.
ערוץ ההיסטוריה בסדרה חדשה המשחזרת את ההמצאות והמכשירים המפורסמים ובודקת אותם מחדש.
This is really evil.
לשרוד את ההיסטוריה. הערב ב-9:50 בערוץ ההיסטוריה.
Bam! Living history. That's perfect.
ההיסטוריה תופסת צורה שכונתית.
Cosmic collisions. They are among the most violent and life-altering phenomena in the universe. From fender benders to high-velocity impacts, gravity is constantly moving everything around in space. And so things are bound to collide. Asteroids, comets, galaxies, and planets are some of the objects involved in these energized events. Yet as violent and destructive as these collisions sound, we may owe our very existence to them. Darren Ragozin is on the hunt for answers to an ancient collision that happened far off in space. Ragozin has zeroed in on a vibrant gray rock. It's the vestige of an ancient fiery impact involving two massive objects, the largest being the size of Pluto. This gargantuan rock, called 2003 EL61, is a member of a collisional family that orbits just beyond the planet Neptune.
Collisional families are groups of objects that have very similar shapes, sizes, and tilts as they go around the sun. They stayed in a tight cluster of orbits because they came from the same objects.
Objects that came from the same parent should be made out of the same material. So by studying the compositions and verifying that they're similar, we can know that they came from the same origin.
Billions of years ago, 2003 EL61 and its family members were part of one gigantic body over 1,000 miles across. The mammoth object resided in the Kuiper Belt, a repository for objects that didn't become planets in the outer solar system. But at that time, the Kuiper Belt was buzzing with loose objects. The ice-covered rock eventually slammed into another object half its size at a speed estimated at 3,000 miles per hour. The impact produced energy equivalent to 10 billion atomic bombs. It also ejected large chunks of ice from the object, each one ranging from 250 miles in diameter down to mere specks. The fragmented pieces are now all members of a collisional family, with 2003 EL61 being the largest piece.
We're here at a clay pigeon shooting range because the trajectory of the shards after a clay pigeon is hit is very similar to the orbits that family members take. And once it's hit, the pieces fly out, but they pretty much follow that same trajectory as they go down.
In the case of 2003 EL-61, the impact has been sending it rapidly spinning like an amusement ride, rotating once every 4 hours.
It got hit sideways, and so it was spinning, and because it's spinning so fast, it elongates itself, pulls itself out, and it's shaped sort of like a football, except it's more like a football where you let out some of the air and squash it on one end. So 2003 EL-61 is the fastest spinning large object that we know anywhere in the solar system. There's nothing else quite like this.
Planetary astronomer Mike Brown has conducted extensive surveying of 2003 EL-61, the biggest and brightest known object in the Kuiper Belt.
It's bright, it's big, but it's also very shiny because we think when the collision happened, most of that ice got removed and the things around it, and it just left a little thin layer of almost pure ice sitting on top of this rock. And that's why it's so much shinier than everything else we see out there. It's that pure ice that's out there. I think that 2003 EL-61 is the largest object out there that had a collision that formed a family. I really do think it's one of the largest collisions that occurred in the outer part of the solar system, in the history of the solar system.
The impact not only created 2003 EL-61 and its galactic family, it also produced 2 moons.
We're searching for them now, and something like 10% of Kuiper Belt objects have moons. But all of these objects that we've looked at, only a few have more than 1 moon.
Infrared telescopes determine the size of these objects by measuring the heat they emit. Although 2003 EL-61 is 100 times larger than its next biggest family member, this fragmented group maintains similar orbits.
The pieces stay together and keep following each other in their orbits around the sun. So astronomers can identify collisional families by looking for common orbital characteristics. So the distance from the sun, how elliptical the orbit is.
When you shoot a shotgun, the pellets go out into similar trajectories as the original object. This is the same as in collisional families in the solar system, which follow similar orbits after the collision as the original object was under. And this is how we're able to identify them. So after this collision happens, they are all in slightly different orbits. And like runners on a track, if they all stayed in their own lanes, if they all ran about the same speed, because the lanes have slightly different lengths, after a while, if you looked at the track, each runner would be at a different place along the track. And this is the same for family members right now. So even though they're not next to each other today, when you look at them, we can still identify each in terms of the way their orbits are, the way they go around the sun.
Scientists wonder whether 2003 EL-61 could eventually be involved in another collision. It seems as though Neptune is gravitationally tugging on it, which will eventually change its orbit.
In 100 million years, it's going to just barely cross the orbit of Neptune. At that point, it's hard to guess what's going to happen. Neptune can either throw it into the inner solar system, or it can try to toss it out, or many different things can happen.
Objects are periodically bumped out of the Kuiper Belt and drift in the direction of the inner solar system. These icy rocks become comets as they form long tails of ice and dust when moving towards our sun.
Eventually, it will work its way perhaps to Jupiter. At that point, Jupiter actually throws it out of the solar system. No one has really thought about what would happen if something the size of 2003 EL-61 hit Jupiter.
But smaller comets have been known to strike the gas giant. In July 1994, the Hubble Space Telescope observed an astonishing event. A string of comet fragments called Shoemaker-Levy 9 crashed into Jupiter at the speed of 130,000 miles per hour. The largest cometary piece released 6 million megatons of explosive energy. They impacted Jupiter about 20 times every 7 hours until they were destroyed. The points of impact left scars on the surface of Jupiter, reminders of the violent event. JPL senior scientist Don Yeomans has analyzed the Shoemaker-Levy 9 event.
The Shoemaker-Levy 9 impacts was an eye-opener for the public and the scientific community in the sense that these cosmic collisions do happen from time to time, and the energy that they can generate are just enormous. It's a good thing this thing hit Jupiter and not the Earth, because it would have been a serious problem on Earth.
Had the Shoemaker-Levy 9 struck Earth, it would have made devastating impact craters, the largest about 40 miles wide. Any one of them could have destroyed a metropolitan city and churned up enough dust to block sunlight for months.
Jupiter, being in the outer solar system and being far more massive than any of the other planets combined, takes a lot of hits that might have otherwise been destined for Earth. So Big Brother Jupiter is out there watching us.
Jupiter acts like a planetary goalkeeper, but will it be able to deflect 2003 EL61 if it breaks loose from the Kuiper Belt and tumbles toward Earth?
It's also possible that it can hit Jupiter like Shoemaker-Levy 9 did. This object is about 2,000 times bigger than the thing that hit Jupiter, than Shoemaker-Levy 9. So it would be an incredible explosion. In the night sky, it would be the single most prominent thing that you could see. It would be bigger than the full moon, at least the tail of it.
Because collisional families are difficult to locate, researchers are eager to study 2003 EL61 and its relatives.
Less is known about collisional families in the Kuiper Belt, simply because fewer Kuiper Belt members are known than we know about asteroids. So less research has been done to try to find collisional families within the Kuiper Belt.
As of today, we know of only this one collisional family in the Kuiper Belt. They're very hard to find and to recognize, and we got extremely lucky with 2003 EL61 and its family. And we're working right now trying to figure out other ways that we might be able to find these additional families, because they must be there, but we just don't know how to find them yet.
Like these clay pigeon pieces, family members in the 2003 EL61 family all remain in similar orbits today. We're able to follow them today and to learn more about the history of the Kuiper Belt and of collisions.
One enduring mystery is when the 2003 EL61 collision actually occurred.
We think we can look at where the different objects are now and try to essentially run time backwards and figure out when they were in this one big collision. Our best guess is that that answer is going to be essentially at the very beginning of the solar system.
2003 EL61 and its family were probably created during one of the most turbulent periods in the history of our solar system, when collisions were as common as stars in the night sky. From the beginning, collisions have been a fact of life in space. They created much of our universe, and at the same time, destroyed some of it along the way.
Collisions are the way that you build planets. Without collisions, you don't have planets to begin with. You start out with very small particles. Each one of them collides together, bigger and bigger and bigger and bigger, until you slowly build up these planets. At the same time, collisions can destroy planets.
The planets in our solar system were created during a period called the Heavy Bombardment that happened over 4.5 billion years ago. And the collisions didn't stop with the heavy bombardment. Over 600 million years later, our solar system experienced another spike in collisions during a period called the Late Heavy Bombardment. Stray rocks, too small to become planets, played interplanetary billiards, striking and bouncing off other bodies with tremendous force.
There were chunks of things flying everywhere, and so there were many, many, many collisions. A lot of the craters that you see on the moon were from that very early period, right when the solar system was still forming.
And our moon reveals just how volatile the period was on Earth.
We can even calculate to some degree, based on cratering on the moon, just how often we got hit by these rather large objects, say 6 miles across.
Towards the end of the late heavy bombardment, we do get asteroids hundreds of miles in diameter coming in and striking the planet. Those are certainly capable of vaporizing the oceans and leaving a tremendous scar where they hit, raising the surface environment far beyond the possibility of any life surviving.
When the late heavy bombardment subsided, approximately 3.8 billion years ago, objects that didn't coagulate into planets sought refuge in cosmic graveyards. In the outer solar system, leftover rocks reside in the Kuiper Belt. In the inner solar system, they collectively orbit in the asteroid belt. Like in the Kuiper Belt, collisional families have also been discovered in the asteroid belt. They're pieces of asteroids that originated from a larger object that was broken apart by a collision with another asteroid.
Collisional families in the asteroid belt result when one asteroid gets hit by another and breaks into pieces. The fragments actually stick together in their orbit around the sun, and astronomers can identify collisional families by looking at their distance from the sun is the same, the tilt of their orbit is the same, and the ellipticity, how squashy the orbit is similar. Also, if we see that the asteroids are made out of the same material, it's a good bet that they may have originated from the same object.
There are approximately 20 to 30 known collisional families in the asteroid belt. Scientists are keenly interested in one galactic collision that produced the Baptistina family, wayward fragments that originated as one single body, the size of Mount Everest. About 160 million years ago, this colossal rock was broadsided by another giant rock in the asteroid belt. The deep impact created a shower of smaller pieces, over 136,000 of them. Scientists estimate that 20% of the rocks escaped the asteroid belt, and 2% of them rained down on Earth. Some say there's a 90% probability that one of the Baptistina asteroids was responsible for the extinction of the dinosaur. 65 million years ago, a myriad of dinosaur species ruled the prehistoric world. But a catastrophic event wiped them off the face of the Earth. Now, scientists have good evidence of what happened to them. It's now been confirmed that a gargantuan cosmic object plummeted down from the sky and exploded in the Yucatan Peninsula near the modern-day Mexican village of Chicxulub.
We think it was an object at about 6 miles in diameter, coming in at about 12 miles per second, which would cause an impact energy of about 65 million megatons of TNT. Now, to put that in perspective, that's about one Hiroshima-type blast every second for about 140 years. It was really quite a hellish environment.
It's believed that this asteroid contributed to the mass extinction of over 75% of the species on Earth at the time.
What we think happened with the Chicxulub impact is you have a large asteroid coming in, it hits the Earth, and throws an enormous cloud of debris and dust into the atmosphere. This effectively screened out a large fraction of the sunlight. So imagine a cloudy day that lasts for years.
Amy Mainzer has investigated the rapid die-off of life as a result of the impact by visiting the Aquarium of the Pacific in Long Beach, California.
We can learn about the effects that an asteroid impact might have had on planet Earth by looking at this nice tank here. We see that it's full of color and life, lots of different species, many different animals and plants. Of course, this whole ecosystem depends